Solve the triangle having a perimeter of 9 units. Angle B and angle C measure are given to us. Okay, let us begin. First, we'll try to understand the problem graphically. So here we have a triangle with vertices A, B and C. The angle measure of B and C that's given to us. So angle B that measures 46 degree and 34 minutes. So B equals to 46 degrees and 34 minutes. But what we'll do, we'll convert the minute part to the degree part. All we have to do is use the transformation. That means 60 minutes corresponds to 1 degree, which means that 1 minute is going to correspond to 1 over 60 degrees. Now since we want to find out 34 minutes, so 34 minutes is going to be equals to 34 divided by 60. So that is going to give us 34 minutes in terms of minutes, and that is going to be approximately 0.57. The degree equivalent of angle B, that is going to be 46.57 degrees. Okay, then we have the angle measure of C. So C is given as 104 degrees and 28 minutes. So we're going to convert 28 minutes to degrees, and that should give us 104.47 degrees. So here we have the angle measure of C as well. So that is going to be 104.47. Angle measure of B, so that's 46.57. Now immediately we can also find out the angle measure of A, since angle A that is going to be equals to 180 degrees minus angle B plus angle C. So solving this, we're going to get angle A measure to be 28.96 degrees. So we have 28.96 degrees, and if we want, we can convert 0.96 degrees to minutes as well. So here again we can use this particular conversion. So we have 0.96 degrees, and if we want to convert it to minutes, all we have to do is take 0.96 and multiply it with 60 minutes. So that's going to give us 57.6 minutes, and that means 0.96 degrees, that's equivalent to 57.6 minutes, or approximately we can say 58 minutes, which means angle A can be also expressed as 28 degrees and 58 minutes. So we have successfully obtained the angle measure for A, that came out as 28 degrees and 58 minutes. Okay, now let's now consider the sides of the triangle. Now the side that is opposite to angle A, which is denoted by CB, we're going to denote it by the letter A in lowercase. Then the side opposite to angle B, so that is going to be the side AC, we're going to denote it by the letter B in lowercase. And the third side AB, which is the side opposite to angle C, we're going to denote it by the letter C. Also, it is given the problem that the perimeter of the triangle is 9 units. That means A plus B plus C, that's equals to 9 units. We're going to label this as equation number 1. Now here what we'll do, we're going to take the help of the law of sines. Now the law of sines states that the ratio of the side A to that of sine of the angle opposite to the side A, so that's angle A, that is going to be equals to the ratio of side B to that of sine of the angle B, equals to the side C divided by the sine of the angle C. So we're going to take help of the law of sine. So here what we'll do, we're going to equate this ratio to a constant, let's call it lambda. And since it's equals to lambda, so here we have A that is going to be equals to lambda times sine of angle A. Then B is going to be equals to lambda times sine of angle B. And then C that is going to be equals to lambda times sine of angle C. So here what we have obtained, here we have obtained the sides A, B and C of the triangle in terms of lambda. So what we'll do, we're going to substitute this back into equation number 1 such that we get lambda multiplied to sine of angle A added to sine of angle B added to sine of angle C, and that is going to be equals to 9, which means that lambda must be equals to 9 divided by sine of angle A. So here angle A, that is 28.96 degrees added to sine of angle B. So B here is 46.57 degrees added to sine of angle C. So angle C that corresponds to 104.47 degrees. So here we compute this value to get the value of lambda. So the lambda value comes out to be approximately 4.131. So that's going to be the value of the constant. Now what we have the ratio equals to 4.131. So we can easily obtain the value of A. So A is going to be 4.131 times sine of angle A. So here angle A, that's 28.96 degrees. So we can plug this value in the calculator. That comes out to be approximately equals to 2. Then we have B. So B is going to be 4.131 times sine of angle B. So angle B, that's 46.57 degrees. And this is going to give us a value approximately 3. And then we have C. So C, that is going to be 4.131 times sine of angle C. Angle C, that's 104.47 degrees. This is going to give us a value approximately 4. So we have obtained the value of A, B, C, and we also found out, so we can say these are the 3 sides of the triangle, and we have angle A that came out as 28 degree and 58 minutes. So we have successfully solved the triangle.